Good evening. Welcome back. TGIF. You believe it? Another week has gone by. It's been an eventful week. Well, tonight I'm going to do something a little bit different. No Fabiola tonight, just going to be me. I told you guys during the live, when we did the JC live, the coverage of the IFT-9. I don't think we're supposed to call it IFT anymore. I think it's just Test Flight 9. All right, we'll just call it Test Flight. Integrated Test Flight just doesn't make sense. I mean, they're always integrated. How else are you going to get it up there, right? It's kind of stupid. Anyways, Test Flight 9. I told you guys that he was going to go live. Elon Musk was going to go live and talk about this roadmap of what they're doing, like where they've come, where they are now, where they're going. And I wanted to cover it live. And they ended up postponing it until finally they did it today, I think it was, and I wasn't available, so couldn't do it. But what I'm going to do tonight, a little bit different, is I'm going to play kind of like a rewind of what he said, the whole thing, and we'll watch it together. And I'll probably do some commentary over it. Maybe I'll pause here and there and ask some questions, but I want to hear it myself. And instead of me watching it and then watching it with you again, I decided not to watch it at all so that we can kind of watch it together. I think it'd be kind of cool just to sit back, and if you guys are into that, just kind of hang out with me tonight, then it'll be kind of cool. And if you have any questions, we'll definitely stick them in there. So put that at JCristina before your question. This way it pops out. It makes it a lot easier for me to find. Before we get too deep in the woods, how's audio sound? I've been working a lot of hours on the different audio things that we have here. We have a Scarlet over here. We have the, what else do we have? We have a Rode over there. We got a Beacon. Just a whole bunch of different audio devices to try to get the audio easier to put together. You know, you can always do it, but sometimes you just want it easier. So I have a lot of different devices. I should probably do a review on all of them. Maybe I'll do that. Anyways, hello everyone. Let me say hello to everybody, and then we'll kind of get into this. Jump into the Elon stuff. How's the audio? Once again, let me know in the chat right now. Let me know. As long as the audio is good, then we're good to go. I'll ask you also how the audio is too when we start playing this video to make sure that it's coming across good. Fragile, thank you for being here. Radioactive Texan is in the house. Who else do we got here? Giles, let's see, John K. Wolf. How you doing, John? Thank you for being here. Another Johnish, Jonathan Rad. William is here. Who else we have? Robbie, thank you for being here. Mark Spencer, Ricky Joe is here. Let's see, Rubicon. It's been a little while. It's been a minute, Rubicon. Thank you for being here, hanging out. Bailey, who else? We got Tim, Casey Douglas. Let's see, John Piney Woods, thank you for being here. So if you're new, you don't know what the show's all about, basically on Fridays we call it Free Speech Friday. It's just like a fun day. We can kind of just talk about whatever happened during the week or whatever you want to talk about. Today obviously it's going to be a little bit of a rehash of what Elon Musk talked about. I think it was today. I'm really interested to hear what he has to say and the direction of the path. We kind of know what it is, but sometimes, you don't know all of the ins and outs. And when he gives these, when he delivers these, I should say, small speeches as he does, it's a really good way to kind of listen to like how he is looking at it and what he's going to do moving forward. Because remember, in the last 40 months, we went from literally like 100,000 people to now almost 6 million people. I mean, that's massive. And Elon, I remember I told you guys this way back, SpaceX Starlink is what's going to get us to Mars. SpaceX Starlink is what's going to make us a multiplanetary society, world. Which is really amazing, really amazing. And that's, people think that, oh, SpaceX is making them a lot of money, or is it Tesla? No, it's Starlink. Starlink is a cash cow. So, that being said, I think we'll just jump right into this video, and I'm going to go, matter of fact, before I start it, let me just see if there's any questions in here first. Let me see. Moving down here, I don't see too many questions. Let's see. Anything here? Once again, if you have a question, at JCristina. And while this is running, I'm going to look at the chat. And if there's something interesting in there, I will pause it and then we'll keep going. So that's I think that's what we're going to end up doing, and that's I think it'll be a good way to kind of make it happen. So here we go. Let's go ahead and let it roll. What we got? You sound good. Thank you so much, Radio After Texting for that. We got a 5 out of 5 on audio. That's good. We got audio 4 out of 10. All right. Well, that's I wonder what's going on with the audio for you, Casey. That's strange. But anyone else having a problem with audio, you let me know. All right. Let me know. I am here. I am here. So let's go. Let's get into this thing.
Yeah. There you go.
You know what? Right. We'll go full screen.
The gateway to Mars. So here we are. Here we are at the newly incorporated Starbase, Texas.
Thank you, Peter. Free memberships from Peter.
This is the first new city made in America in, I think, quite a few decades. At least that's what I'm told. And very cool name. And it's named that because it is where we're going to develop the technology necessary to take humanity and civilization and life as we know it to another planet for the first time in the 4.5 billion year history of Earth. So go with this little video here. This is how it started off, with basically nothing. So Starbase started off as basically a sandbar with nothing. Even those little things we built, obviously. That's the original sort of Mad Max rocket.
It looks like you're in a clean room, right?
This is where you discover lighting is very important for that Mad Max rocket. So yeah, not that long ago, there was basically nothing here. And in the space of about 5 or 6 years, thanks to the incredible work of the SpaceX team, we've built a small city. And we've built 2 gigantic launch pads and a gigantic rocket factory for a gigantic rocket. And the cool thing is, for anyone out there who's watching this, you can actually come and visit because our entire production facility and launch site are on a public highway. So anyone who comes to South Texas can come and see the rocket pretty close up and see the factory. And so anyone who's interested in seeing the largest flying object on Earth can come here anytime they want and just drive down the public highway and see it, which is pretty cool. So then we progress to where we are now, Starbase 2025. So we're now at the point where we can produce a ship roughly every 2 or 3 weeks. Now, we don't always produce the ship every 2 or 3 weeks because we are making design upgrades. But ultimately, we're aiming for the ability to produce 1,000 ships a year, so 3 ships a day.
Elon Musk is from South Africa.
So that's where things are now. I'm standing in that building. That's our hovercraft. We're driving a booster down the road to the launch site. You can see the mega bays.
The size, the absolute scale, it's unbelievable.
And as I said, what's cool, the cool thing for those out there watching this video is that you can actually just literally come here, drive down the road and see it, which is the first time in history that that's been possible. So all this cool stuff, that road on the left there, that highway is public, and you can just come here and see it, which I recommend doing. I think it's very inspiring to see. So that's our gigabay. So we're expanding integration to produce 1,000 Starships per year.
1,000 Starships per year. Holy crap.
Yeah, that hasn't been built yet, but we're building it. That is a truly enormous structure. This will be that'll be one of the biggest structures, I think by some measures, the biggest structure in the world. And it's designed for 1,000 Starships a year. We're also building a gigabay in Florida, so we'll have 2 facilities, one in Texas and one in Florida.
There you go, hurricane, Eric. Hurricane on both coasts, Texas and Florida.
Kind of human for scale. When you see how tiny a human is next to that building, you realize just how enormous it is. So when we look at our build comparison, vehicles per year, so you look at Boeing and Airbus making airplanes, Starship will be making, at some point, probably as many Starships for Mars as Boeing and Airbus make commercial airplanes. So this is really at a scale, enormous scale. And each Starship will have a capability. Each Starship is bigger than a 747 or an A380. Like, it's truly enormous. And then in terms of Starlink satellites, the version 3 satellites, making on the order of 5,000 a year, maybe at some point closer to 10,000 a year. And those Starlink V3 satellites are each the size of roughly a 737. They're pretty big. That compares to the B-24 bomber in World War II. Now, it's still small compared to Tesla. And Tesla will probably be doing, double or triple that volume in the future. So it just puts things into perspective that it is actually possible to build a vast number of interplanetary starships. And even when you can compare things on the tonnage standpoint, Tesla is still, and other car companies are still building far more complex manufactured tonnage than SpaceX, which just really is a way of saying that it's very achievable. Like these numbers, while they are insanely high by traditional space standards, are achievable by humans because they have been achieved in other industries. Progress is measured by the timeline to establishing a self-sustaining civilization on Mars. That's how we're gauging our progress here at Starbase. So with each launch, especially in the early days of Starship, each launch is about learning more and more about what's needed to make life multiplanetary and to improve Starship to the point where it can be taking ultimately hundreds of thousands, if not millions of people to Mars. Ideally, we can take anyone who wants to go to Mars, we can take to Mars. And bring with it, bring all of the equipment necessary to make Mars self-sustaining, so Mars can grow by itself in a worst-case scenario, getting to the point where the fundamental fork in the road for human destiny is where Mars can continue to grow even if the supply shifts from Earth stop coming for any reason. At that point, we've achieved civilizational resilience, where Mars can potentially come to the rescue of Earth if something goes wrong, or maybe Earth could come to the rescue of Mars. But having two planets that are both self-sustaining and strong I think is going to be incredibly important for the long-term survival of civilization. So, like, just I think any given civilization is likely to last maybe, I don't know, 10 times longer, maybe much longer, if it is a multi-planet civilization than if it is a single-planet civilization, because there's always some chance that, you know, us humans could do something crazy like World War III. Hopefully not, but it's possible, or that there could be some natural event like meteors or supervolcanoes or something that we don't expect, and then if we only have one planet, then that could be curtains. But if we've got two planets, we keep going, and then we go beyond Mars ultimately to maybe the asteroid belt, the moons of Jupiter, and beyond, and ultimately to other star systems, and we can be out there among the stars, making science fiction no longer fiction. So in order to achieve this goal, we have to make rapidly reusable rockets, so that the cost per flight, the cost per ton to Mars, is as low as possible. That's essential. So for that, rapidly reusable rockets, I said, it's actually 4 R's. It's like a pirate. RRR. It's like rapidly reusable, reliable rockets is the key. RRR. Now we've congrats to the SpaceX team on making incredible progress on catching a giant rocket. So it's really mind-blowing that the SpaceX team has been able to catch the largest flying object ever made multiple times, using a very novel method of catching it out of the air with giant chopsticks.
This never gets old, guys. This just never gets old. I don't even know. And it's literally within an inch. It's like centimeters. It's crazy.
I mean, have you ever seen that before?
It's insane. Absolutely insane. It is just crazy.
Yeah, congrats again. That was an incredible achievement. So the reason we are catching it in this way, which has never been done before, is in order to achieve the rapidly reusable portion of in order to make the rocket rapidly reusable. So if the super heavy booster, which is gigantic, it's like 30 feet in diameter, if it were to land with landing legs on a landing pad, we would then have to pick it up, stow the legs, and put it back in the launch pad. And it's quite difficult to transport such a large thing. But if we catch it with the same tower that it's used to put it in the launch mount to begin with, that is the best case outcome for rapid reuse. So it literally gets caught by the same arms that placed it in the launch ring, and then it is placed back in the launch ring immediately. So in principle, the Super Heavy booster can be reflown within an hour of landing. So it comes back in about 5 or 6 minutes, one way or another, and then it gets caught by the tower arms, placed back in the launch mount, and then you can refill propellant in about 30 to 40 minutes, and place a ship on top of it, and in principle, refly the entire booster
Maybe a
every
couple
hour.
hours?
Maybe every 2 hours to give it a little bit of extra time. But let's
Crazy.
just say it's
Crazy.
it's in the limit of rapid reuse. And then the next thing we need to do is catch the ship too. So we haven't done this yet, but we will. So that's what we hope to demonstrate later this year, maybe as soon as 2 or 3 months from now. And then the ship would be placed on top of the booster and then again refilled with propellant and flown again. With the ship, it takes a bit longer because it's got to orbit Earth a few times until the ground track comes back over the launch pad. But the ship is also intended to be reflown multiple times per day. This is the new Raptor 3, which is an awesome engine. Big hands to the Raptor team for this. This is very exciting.
Thing's amazing. It literally looks like something out of Star Trek.
So Raptor 3 is designed to require no base heat shield, saving a lot of mass on the bottom and actually improving reliability so that if there is, for example, a small fuel leak from the Raptor engine, it will simply leak into the existing flaming plasma and not really matter. Whereas a fuel leak, when the engines are contained in a box, is a very scary thing indeed. So this is a Raptor 3. It'll take it probably a few kicks at the can, but it is a massive increase in payload capability, in engine efficiency, and in reliability. So this is really a revolutionary engine. Raptor 3 is really, I'd say, kind of alien technology rocket engine.
Exactly.
I mean, even industry experts, when we showed a picture of the Raptor 3, said that engine is not complete. So then we said, well, here's the engine not complete, firing at a level of efficiency that has never been achieved before. So
I'm telling you. The Raptor 1 looked like a spaghetti mess. It literally looked like spaghetti.
that is one clean
This thing
engine.
is like clean.
So in order to make the
Efficiency.
engine like that, we had to simplify so many parts of the design, incorporate secondary fluid circuits and electronics in the structure of the engine itself. So everything is contained and protected. It is a marvel of engineering, frankly.
Amazing.
Then one of the other technologies that's key for Mars is doing orbital propellant transfer. So you can think of this like similar to aerial refueling for airplanes, but in this case it's orbital refilling of rockets, which has never been done before. But it is, technically feasible. I always feel like these things are a little NSFW, sort of. Listen, you got to transfer fluid somehow. This has got to be done. So the two starships would get together, and one starship would transfer fuel and oxygen. And actually, most of the mass is oxygen. It's almost 80% oxygen that gets transferred, a little over 20% fuel. And so once you send a starship to orbit with that's full of payload, and then you send a bunch of other starships up, and you would refill the propellant on that starship. And once the propellant tanks are mostly full, then you can depart for Mars or the Moon, or yeah. So this is an important technology which we should hopefully demonstrate next year. So.
On-orbit refueling. On-orbit refueling. Amazing.
So then with One of the toughest problems to solve is the reusable heat shield. So no one has ever developed a truly reusable orbital heat shield. So it's extremely difficult to do so.
Remember with the
Even
space shuttle?
The shuttle's heat shield required several months of refurbishment, basically fixing broken tiles.
It was in several. It
testing
was like
each tile,
8 or 9 months.
And because it's an extremely hard problem to be able to withstand the extreme heat and pressure of reentry. The only things that can really withstand this level of heat are advanced sort of ceramics, basically glass, alumina, some types of carbon, but very little actually can survive the with reusability without eroding or falling off or cracking, can survive the stresses of reentry. So this will be the first time that it's done, that a reusable orbital heat shield is developed, and it needs to be obviously extremely reliable. So this will be something that we'll be working on for a few years, I think, to keep honing the heat shield. It is an achievable thing, so we're not trying to do something that isn't achievable. It is within the realm of physics to get this done, just an extraordinarily difficult thing to get done. And Mars, the Mars atmosphere is carbon dioxide, which at first may seem better, but actually it ends up being worse because when the CO2 turns into a plasma and you actually end up with more free oxygen entering on a Mars atmosphere than on Earth atmosphere. So Earth's atmosphere is only around 20% oxygen, and Mars ends up being basically more than double that, maybe triple that, when you consider when the CO2 becomes a plasma and you get carbon and O2. So that wants to oxidize the heat shield, basically burn the heat shield. So that's why we tested very rigorously in a CO2 atmosphere, because it's got to work not just for Earth, but also for Mars. And we want to use the same heat shield for Earth that we use for Mars, because there are many other factors with the heat shield, such as making sure the tiles don't crack or fall off or anything like that. So we want to have the same heat shield structure, same material on Earth as on Mars, so we can test it hundreds of times on Earth before going to Mars, and be confident that when it goes to Mars, it will work. So we're developing some next generation Starships, which have a number of improvements versus our current gen. So it's taller, for example, and has a better the interstage between the ship and the booster. You can see that sort of the sort of struts there. That makes it easier for the flame. Like that right there. When doing hot staging, which is when we light the ship's engines while the booster's engines are still firing, the flame from the ship engines can more easily exit through the open struts of the new interstage. And in this case, we'll bring the struts interstage back with us instead of throwing it away. So a little more height here, 72 meters from around 69. Propellant capacity, I think we'll probably push that up a little, maybe 3,700 tons.
I think it was like 25% more propellant.
Long term, my guess is we're maybe around 4,000 tons. And about just over 8,000, I think probably like 8,300. This will keep getting up. My guess is ultimately we're 4,000 tons here, close to 10,000 tons of thrust. But this is kind of the next level, or the next version of the Super Heavy. So the booster will look a little naked on the bottom because the Raptor 3 engines don't require a heat shield.
No heat shield.
So it looks
That's
like
just crazy.
it looks like there's kind of parts missing, but that's just because the Raptor heat shield does not. The Raptor 3 does not need a heat shield. So it's just standing there in a bathed in flaming plasma.
That's just sick. What material is that
That's a lot
made out
lighter.
of, guys? What material?
Yep.
Because we see the stainless
Integrated.
steel on those flaps just start melting
stage.
off it, right?
I think it looks amazing. And then the ship's a little longer, a little more capable. Moving to 1,550 tons of propellant capacity. And my guess is this probably ends up 20% more than this long term. Yeah, you can see the heat shield is sleeker, so much smoother boundaries. As the boundary of the heat shield going to the leeward side is very smooth. No more jagged tiles. I think it looks very sleek.
It's like, oh, it looks good. Well, does it work?
And this version, we still have 6 engines, but a future version will have 9. But with the Raptor 3, again, we have improved
Thrust.
reduced mass, higher specific impulse. This is the Starship version 3 is really the version that is, I think, achieves all of the key elements. I mean, generally with any new technology, it takes three major iterations of any new technology to have it really work well. And this, with Raptor 3 and Starship and Booster version 3, it should be able to achieve all of the things that I just mentioned, which is a rapidly reusable, reliable rocket with orbital refilling. Basically, all of the ingredients necessary to make life multiplanetary will be achieved with version 3 of Starship, which we're aiming to launch for the first time at the end of this year. Yeah, so you can see this is kind of where things are on the left, where things will be end of this year in the middle, and as I was saying, kind of where things will be probably long term. Yeah, 142 meters. So, but the one in the middle will be fully capable of doing Mars, and thereafter it'll be a lot of performance improvements, and as has been the case with Falcon 9, we always end up making the rocket longer and increasing payload. So that's the game plan. Pretty straightforward, but it's important to emphasize, even with the rocket that we'll be launching just at the end of this year, it will be capable of making life multiplanetary, and thereafter it's just about continuing to hone the efficiency and capability of the rocket, and reduce the cost per ton and reduce the cost per person to Mars, and like I said, ultimately make it so that anyone who wants to move to Mars and help build a new civilization can do so. So anyone out there, like, how cool would that be? And even if you don't want to do it, maybe that you have a son or daughter who wants to do that, or a friend who wants to do it, and I think it would be the best adventure that one could possibly do, is to go and help build a new civilization on a new planet.
Who's going, guys? Who's going? I ain't going.
So yeah, ultimately we'll have 42 engines, which it was inevitable.
42.
As the prophecy foretold by the great prophet Douglas Adams in his the
book,
The Hitchhiker's Guide to the Galaxy. The answer to the meaning of life is 42, and so inevitably the Starship stack will have 42 engines. And in terms of payload to orbit, what's remarkable is that it's 200 tons of, Starship will have 200 tons payload to orbit with full reusability. So this is twice the capability of the Saturn V moon rocket. The Saturn V moon rocket was fully expendable. Starship is fully reusable, but will have twice the payload to orbit of the next biggest rocket that made it to orbit, which is the Saturn V. In fact, without reusability, Starship would have about 400 tons of payload to orbit. So
Jeez, 400
this is a very big rocket, is what I'm saying. So, but you need a big rocket, to make life multiplanetary. And then along the way, we could do very cool things like have a moon base, like Moonbase Alpha. I think long ago there was a TV show about Moonbase Alpha. You couldn't think about the physics of that too much because apparently like the moon base was like drifting away from Earth. But anyway, we should have a Moonbase Alpha, which is the next step after the Apollo program would be to have a base on the moon. So you could have a gigantic science station doing research about the nature of the universe on the moon. Would be very cool. So in terms of when can you go to Mars? So you can go to Mars every 2 years or every 26 months. So the next Mars opportunity is at the end of next year in about 18 months. So November, December is the next Mars opportunity. So we'll try to make that opportunity if we get lucky. I think we'll probably have a 50-50 chance right now because we've got to figure out orbital refilling in order to have enough capability to go to Mars. But if we achieve orbital refilling in time, then we will launch the first uncrewed Starship to Mars at the end of next year. So
that's what I've been talking about for the last couple of months, that they need to get it right. They don't have a lot of time. The window is only a couple of months.
How does a spaceship go from Earth to Mars? So you got blue Earth there and red Mars. And I mean, the actual distance traveled on the Ark is close to like 1,000 times further than the moon. So you can't just go straight
You don't want to
Mars.
miss it.
You have to create this elliptical orbit with Earth at one point and Mars at the other side, at the far end of the ellipse, and then time the where you are in that ellipse to intersect with Mars. And this is the orbital transfer, how you do orbital transfer from Earth to Mars. And if you look on your Starlink Wi-Fi router, you'll see this image.
Symbol.
Because the Starlink Wi-Fi is Starlink Internet is what's being used to pay for humanity getting to Mars. So I'd just like to thank everyone out there who's bought Starlink, because you're helping secure the future of civilization and helping make life multiplanetary and helping make humanity a space-faring civilization. Thank you. So this is a tentative game plan here, where we're hoping to achieve, where we increase the cadence of flights to Mars dramatically with every launch window. So every roughly 2 years, we are dramatically increasing the number of ships that go to Mars, and ultimately try to get to 1,000 or 2,000 ships, per Mars rendezvous.
That's every 2 years. That's a lot of ships.
I mean, as a rough order of magnitude, this is just guesses, obviously, but we need to get about 1 million tons, is my guess, to the surface of Mars to make a civilization on Mars self-sustaining, and getting to that critical point where if the resupply ships from Earth stop coming for any reason, Mars still succeeds. Mars can still grow. And so you can't be missing anything. You can't be missing even like the equivalent of vitamin C or anything. You've got to have everything you need for Mars to grow. That's essential. So my guess is that's about 1 million tons, but it might be 10 million tons. I hope it's not 100 million tons. That'd be a lot. But we want to try to get to that point and secure the future of civilization as quickly as possible. So we're looking at different locations. The lead candidate right now is the Arcadia region. So now Mars has a lot of real estate, but when you combine all of the factors and say, okay, we can't be too close to the poles. We need to be near ice to get water, and can't be too mountainous for the rockets. Then it narrows down to a smaller region. So Arcadia is it's one of my daughter's name is Arcadia actually, and is one of the options. So we got the first Starships on Mars, gather critical data. So the first flights there we'll send with the Optimus robot, so we can go out there and explore and kind of prepare the way for humans. And that'll be a very cool image if we're able to achieve it by launching end of next year. It would actually technically arrive in 2027, but that would be an epic picture to see Optimus walking around on the surface of Mars. And then with the launching 2 years later, we'd be sending humans. Assuming the first missions are successful and they land successfully, we'd send humans on the next mission, and we'd really start building the infrastructure for Mars. So anyway, maybe just to be safe, we might just do two landing episodes with Optimus and do the third one with humans. We'll see. So that classic picture of the workers on the Empire State.
They're missing their sandwich and their booze.
And then for communications on Mars, we'll be using a version of Starlink to provide internet on Mars.
I wonder if they're going to talk about how they're going to get the connection back to Earth.
The speed of light, even at moving at the speed of light, your best case scenario is, I guess, I think around 3.5 minutes to Mars, and then worst case is 22 minutes or more because Mars is on the other side of the sun from Earth.
We've talked about this, guys, right?
So anyway, it's quite challenging to do high bandwidth communications with Mars. But Starlink will achieve that. Yeah, and then we'll have the first humans lay the groundwork for permanent presence on the surface. And yeah, the goal, like I said, will be to make Mars self-sustaining as quickly as possible. So it's just a sort of rough idea of what things will be like with the first city on Mars. My guess is we'll probably put the launch pads a little further away, or the landing pads, just in case. But I mean, for Mars, we're going to need a lot of solar power. We'll be, since you can't really walk around on the surface of Mars, at least as yet, until Mars is terraformed to be like Earth. You need to walk around with a Mars suit. And be, initially in kind of like glass domes. But it would work. And eventually we can make Mars into an Earth-like planet. And we want to get to the point where we're transferring over 1 million tons at every Mars transfer window. And then that's like a serious civilization.
1 million tons every 26 months. Can you imagine?
So, yeah, I have a lot of spaceports. I mean, because of the fact that you can't fly there continuously and you have to transfer in these windows, you'd have a gathering of 1,000 ships, or 2,000 ships, or more than that. So we have this kind of like Battlestar Galactica feel where all these ships are in orbit, waiting to depart, and then they'd all depart. I think an amazing image of all these ships departing at once. And then you're going to need, obviously, a lot of launch pads, a lot of landing pads on Mars. or you'll need to move the ships off the landing pad pretty fast. So if you got I don't know, a few thousand ships inbound, probably need at least a few hundred pads, landing pads, and anyway, we'll solve that problem later. So yeah, anyway, this is like an incredible thing to have, like this amazing city on Mars, the first city on another planet, and a new world. And it's also an opportunity to, I think, for the Martians to rethink how they want civilization to be. So you can maybe rethink, like, what kind of form of government do you want? What new rules do you want to have? There's a lot of freedom and opportunity in Mars to do a recompile on civilization, which will be up to the Martians. So, all right, let's get it done. Thank you, everyone.
Crazy guys, right? Absolutely crazy. I love it. I absolutely love it. This is the kind of stuff that, you know, you would only, you know, when you get a little bit older, you remember like Star Wars, right? Star Trek. And, you know, just to see stuff like this, it's like, this isn't even possible. I mean, and it is, and they're actually doing it. That's why I always say, like, when you actually see them catch a super heavy in those chopsticks, this mass, this structure that's the size of a building, that was just at, what, 150 kilometers, whatever. You're just, it's just, to me, it's absolutely amazing. Absolutely amazing. So, and then it just lands right back on the pad, and it's ready for refurbishment and send it back up. That is just crazy. That is just not, you know, I wouldn't even, you know, you couldn't even guess this type of thing. I wish he got into the communication, because he did allude to putting SpaceX Starlink on Mars, right? Which is absolutely the case. They're going to do that. They're going to be SpaceX Starlink also on the moon, or orbiting the moon. But what he didn't say, and what is a necessity, no matter how you look at it, physics doesn't lie, you would have to have substations between Mars and Earth. There has to be relays, because if not, it's just not going to work. Because he was talking about the speed of light, right? And so the fastest that we can communicate through a laser communication device from Mars to Earth is about let's just call it 3 minutes, 3.5 minutes, something like that, right? And that's when Mars is at its closest point. But when it's at its furthest point in that elliptical journey that we take, it's like 20 minutes, right? So it's a big, big difference. But what makes it even worse is that laser, even though a laser, you think about it as this tiny, tiny beam, right? But as it goes further and further and further, it slowly starts spreading out like a cone. And if you were just, for example, if you were to shoot a laser from Mars to Earth, and it was at its closest distance, and it took 3.5 minutes for that laser to reach us, let's say, it wouldn't be the size of a dime, right? It wouldn't be the size, it would probably be the size of like a kilometer or two, okay? It would spread out like this. So what would happen is you wouldn't be able to catch the data, because the data is spread all over the damn place. You follow me? So this is why I'm saying they need to have some type of repeaters, some type of substation, some type of, let's call it a repeater that's sitting in that arc, so that they can actually now use it almost as a network, a mesh network, and beam from Mars to, let's say, X number of, 1,000 kilometers to the next 1,000, so on and so forth. And then once they get that data, okay, you're not going to just reflect the data and let it keep going. You have to then take the data, process it, and then refire it off again. That means each one of these substations, in my personal opinion, are going to have to be nuclear. They're not going to be able to do it with with just standard generic solar panels. There's just not enough power there, I don't believe. You're just going to need more, in my personal opinion. So, but that's not a big deal. There's a lot of satellites already out there that are running nuclear that actually go out of our solar system. So that's not a problem. But I wish he got into that a little bit, because I've been speculating about this for a while, and I would love to be able to ask him that question. So how exactly do you get that laser communication from Mars to Earth? I mean, I've come up with my theories on how to do it, and I can see it in my mind. But is that how they do it? I don't know. I really don't know. Maybe they have some new form of communications or laser that will be able to somehow circumvent standard physics, which, as far as I know, you probably can't. Maybe it's some quantum crap. That's a possibility. I'm not going to get into quantum. But anyways, wow, thank you, Ian. Ian's here. He's been a member 3 months, premium sub. Thank you so much for that. Really do appreciate that. Really appreciate that, guys. So if you have any questions, let me know. Put, once again, at JCristina in the chat, and we'll kind of shoot it a little bit, hang out and talk about it a little bit, and then I'm going to head out. So we're not very long tonight, right? Just going to make it a little bit shorter for you guys. But for the most part, you know, when I look at what they're doing here, I just think it's absolutely amazing, and they're doing it well, right? And you know, they're going to be blowing some stuff up, and just like he said with the Raptor engine, I mean, look at that new Raptor 3 with no heat shielding at all. It's just going to be sitting in the plasma, and it's going to be fine. That is crazy. That is absolutely crazy. And you know, when I was going over some of the facts that went into the last RUD, where it blew up, and you know, there was a lot that was going on with this last one, and I was kind of like poo-pooing it a little bit. And yes, I understand that they're learning a lot, but they blew up 3 in a row now, right? And this time they probably didn't have to blow up the Super Heavy, but I think what they did is they looked at the Super Heavy as a, you know, expendable type of thing. And they said, you know what, we're refurbishing it anyways. We're just going to do, you know, 2 and done type of thing instead of, you know, the 1 and done thing. So, and if 2 works, then great. And I think that's why they brought it in at that extremely much greater angle of attack. So it would just, I'm sure that it was vibrating and burning and plasma pouring off of it that we didn't see. Okay. And if you don't know, basically, normally when the Super Heavy comes back, when it gets caught in the chopsticks, right, it comes back and it's more like this. It's like about let's say 15 degrees. That's how it's coming in, like this, right? So it's really cutting through the atmosphere, almost like a diver, right, coming into the water like this. Well, imagine that diver, instead of going into the water like this, going into the water with like the swan dive, a belly flop. And that's what they were kind of doing. So instead of coming in like at that nice angle like this, where they're just cutting through it, they came in more like this. It's about 30, 40 degrees more. That 30 or 40 degrees put so much heat and pressure on this thing, I guarantee you that thing was vibrating. It was burning up. But it allows it, that extra 20, 30 degrees, my understanding, if you do the math, it allows it to slow down by about 60,000 kilometers. Let's say about, I would say slow down by about 1,000 to 1,100 kilometers slower. So, you know, you're looking at, let's say coming in at, let's just give it a number at like 5,000, right? You're coming in at 4,000. So by doing that, it allows you to use less fuel to do the flip and then burn, that landing burn, right? You're going to use less fuel because it's going slower. An extra 1,000 is going to use, obviously, more fuel. So they're trying to see how much stress they can put on this thing at that, really, let's call belly flop, so that it can actually use the atmosphere to slow it down. So I think it worked out pretty good. Okay, originally I was looking at it, I'm like, maybe they popped its cork and they just pulled the trigger just before it landed. And I was thinking about it, I'm like, they wouldn't do that. It wouldn't make sense. So it probably did blow up. It just didn't. It didn't make it because once again, it was burning up, shaking up, rattling. Who knows? Who knows? Harmonic. Like that whole. Remember the last ship? What was it? Ship 7 with the harmonic problem that it had. That episode where it starts shaking very softly, very slowly, and then all of a sudden the shake gets more and more and more violent until it's ripping out hoses and pouring out fuel. So that's what ended up happening with that. And then they fixed that in Ship 8. You didn't have any of this harmonic response problem anymore. It's kind of like a tuning fork. Like, you hit the tuning fork and it starts vibrating really high, really sharp, like at first it's really tight, and then it gets more and more and more until it's like vibrating like this. Well, that's what ended up happening. So with this last one, they're going to go through all of the figuring out with the FAA and themselves to see what went on with this. But I just don't like to see the Starship, once again, not be able to deploy the version 3 satellites that they were supposed to. The Pez dispenser at the top, at the cone, at that top fairing, that Pez dispenser door didn't open fully. It's supposed to have opened fully, and then they were going to launch out eight SpaceX Starlink version 3 duds, lookalikes, mass structures. So supposedly these things were like satellites in mass, in volume and size, so that they can shoot them out and they know that the actual satellites would work, but they weren't able to do it because the door didn't open up fully. And then they had to close the door again to try to bring this thing home. And obviously it didn't matter at that point because the whole rocket was doing this, right? It was doing that tumble, the death spiral. And they took the telemetry off, and I'm like, yeah, that's pretty much, that's game over there. So anyways, it kind of is what it is. But moving forward, I mean, I was really, really interested in what what he was going to do with this whole, the Mars thing. And someone, matter of fact, in the chat said, we really should get on the moon, get the moon, put a base on the moon, and then, then move on from there. I don't think Elon's going to do that. I think moon is going to be like a side hustle, let's call it. Maybe he'll allow that to just go through Artemis, and let Artemis, let NASA and stuff do their thing, and they can figure out all that crap. His mind is stuck. He's stuck on Mars, and he's going to get there before he's dead. Maybe not him personally, but maybe one of his robots or human before he's gone. And that's what his goal is, and don't tell him anything different. He's going to get it done. So the other thing I wanted to know from you guys, what do you think about this whole gigaplant and how not only are they going to be putting out 1,000 of these SpaceX Starships per year, which is insanity. I don't even know how they can do that, but obviously they can. What do you guys think about all of the tens of thousands, hundreds of thousands of the Tesla robots that are going to be in everyone's homes? I'm excited for that. I'm like really into the whole robot thing. And I mean, my wife, not so much, but me, I would love it. I think that would be just freaking awesome. Absolutely awesome. What say you guys? You want a robot? You want a Tesla bot? I just think it would be kind of cool. Even if it didn't do much, it was just kind of like hanging out, just chit chat, talk with it. I don't know. It'd be kind of interesting. Once again, if you have a question, put at JCristina. I'm going to answer some questions in the next 5-10 minutes, and I'm going to see you guys in the next one, most likely on Monday. I have a bunch of work to do on this audio stuff, and I think I'm going to do a video on it, this whole trials and tribulations that I've gone through, and maybe it will help other people that have, that haven't gone through it yet, and this way they don't have to go through all of the stuff that I did and all of the testing that I've done for countless hours. Is just crazy, absolute crazy. Let's see. Let's see. Once again, if you have a question, put at JCristina, and I will see it in here. What do we got here? Memorable Place says, why bother with laser communication? Why not just use traditional radio waves? You don't need a booster or relays. That's true. Yeah, you can absolutely do radio waves, RF, anything. For the most part, obviously it's going to be a little bit slower, and lasers are usually if possible they're going to want to use lasers, right? But because once again, it is moving extremely quickly, right? Lasers are moving at the speed of light, but then also in a vacuum. So people don't realize this, but laser communication on orbit in a vacuum is faster than laser communication in a cable on Earth. Any type of terrestrial laser. So it is definitely a good form of communication, but the dissipation of the laser over the course of kilometers is definitely something that needs to be addressed. The accumulator, let's call it, the antenna or whatever that has to be on each one of these is going to have to be proportional to the distance. And so they might have to be really big. If the distance is far, they'd have to be pretty big or they're going to be losing a lot of data, right? Once again, it starts out the size of a tiny a pin. Then all of a sudden, it's very quickly the size of, a kilometer, depending obviously on distance. So you'd have to do it at some relatively nearer distances, let's just say. That's just once again, I'm speculating. I'm not a rocket engineer of any kind, but just thinking about it, that's just my physics brains and all the stuff that I used to do in college. I think a little bit differently on how this stuff works, and sometimes I'm right, sometimes I'm not. So we'll see. That's why I wish he talked about that. I think it would have been great. It would have been a good conversation. I would love to have heard that. How they intend to do it. But yeah, absolutely, memorable places. You could definitely use radio waves. That is definitely a possibility for sure. Puerto Rico is in the house. Eduardo, how are you doing? I enjoy the Starship launch here in Puerto Rico. Views are something that you see past the 11 minutes after the flight. Yeah, it's true. You can, and that's why people in Puerto Rico, people in the islands, when the thing blows up, they can actually see it blow up and come crashing, down. People see it blow up and then they get all worried. I remember there was a close friend to the show, and my wife and I, and he was saying, how this thing blew up overhead. And the thing is people, I remember in the video, they get all like nervous and they're crazy. They're like, oh my God, if you could see it overhead, that means that at 100, kilometers or whatever it's at, 60 kilometers, when you could see it overhead, you could just rest assured it's not going to land for many miles in the opposite direction. You're pretty much good. Now, if it blew up like 100 miles in this direction of you, well, then you might have an issue. But they deliberately have these areas where they can explode. So, like for example, when they launch them, they literally launch them like in between Cuba and Florida. Like there's a specific trajectory. So if something went south, there's still like this corridor of safety. So they're very meticulous. I mean, it's done to the inch. They're not guessing with this stuff. So, but anyways, Tim, thank you very much there for the question. What does Tim have here? It says, just wanted to say an early Father's Day gift. Thank you so much for you said that. Was Starlink Mini. Wow, that's always good. It was on sale for $299. That is awesome. Yeah, $299. I did see the minis at $299. I'm like, wow, that's pretty damn good. You can't beat that. I mean, can't beat that. I mean, I paid $599 for the one that we have on the roof. So yeah. Let's see. Mick says, if Tesla robot can be purchased at $15,000, we are buying one. Yeah, it would be like the equivalent of buying like half a car, I guess. I don't know. Maybe not even a third of a car. But if you got like 10, 20 years use, just upgrades and stuff to your Tesla bot, that'd be kind of cool, right? It'd be pretty neat. I mean, I don't expect it to sit there and do laundry or something, I don't know. Let's see. I don't want it to be an iRobot either, right? With Will Smith over there. Let's see. Ricky Joe says, how many IFTs not blowing up you think it will take for humans to be compatible? Okay, so yeah, well, I think what they're doing right now is they are at a point where they are trying to blow these things up, just like I said with the Super Heavy, they push that thing to the limit to blow it up because they wanted to know what it can withstand. Because remember, you could do whatever you want when there's no one on board, but if there's someone up there, you're not doing any of that, okay? You're going to play it very safe. So by pushing these things to their absolute limit when no one is on board, because they are something that it's expendable. They are going to land in the ocean. They are going to be lost anyways, unless it's like a Falcon 9, which you're going to catch and you're going to bring back. But at that point, you might as well push the hell out of it and see what it can withstand so that in case there were humans on board at one point and now you have to do a quick return, you know exactly how much fuel is on board and how deep or how much of an angle of attack you would have to make to be able to have enough propellant to be able to land it safely. These type of things, you would know that algorithmic equation if you didn't have an answer or a close answer real world. I don't give a shit about any of the computers doing all of their nonsense, right? All of the AI and all the rest of the crap trying to figure out and doing all the math that supposedly is going to tell you. No, it doesn't tell you. Doing it real world is really what tells you. And there's a lot of things that they have calculated that they thought was right. And then when they actually do it, they're like, oh crap, we didn't take this one variable into account. And that just throws the entire equation out, right? Because that one variable might be proportional to another one. So there's something to be said about actually doing it and quote unquote blowing shit up. And that's what his goal is to blow it up as fast as possible, iterate as fast as possible so they can innovate. These iterations have been doing well. What's been happening is the innovation when they went from a block 1 to a block 2. That's really when crap hit the fan. Right? Block 1 was doing pretty damn well, and then Block 2 came out, and there was so many modifications that happened. It's just, I don't think they were able to keep up with all the problems that they ended up. And that's what happens sometimes. But you need to do that to be able to progress. If not, you just have to stick with an old, tried and true thing, and you never progress to anything better. That's like if you use the original Raptor 1 engine in comparison to these Raptor 3s that are not even on par. They're just completely, I think it's like 1,000 pounds, I think it's 1,000 tons extra of power, and the mass is like 25% or 30% of that. It's completely crazy. It literally looks alien. Those engines, the Raptor 3s. It's like, I don't even know. So anyways, yeah. Let's see. Moving on to Tim said Tesla bot would be cool to have, but would want to control privacy. Oh, yeah, of course. And what he shares back with, of course, whatever it's going to be phoning home with. Bad enough Bozo listening to us with Alexa, yeah. Jeff Bezos, or as I call him, Jeff Bozo over there. Alexa's been listening to us forever. Our iPhones, I don't give a crap. Anyone that thinks the iPhone is not listening, even when you have everything turned off, is delusional. Don't kid yourself. It's listening all the time. I promise you, shut it off, okay? And then start talking about a red Corvette or a red Mustang. And then make it even more, let's say, deliberate, right? Exacting. And say, red electric Mustang. That's a little bit odd, right? Red electric Mustang. Keep saying red electric Mustang. And you might not get a red one, and you might not get a Mustang, but within a day, you're going to get an advertisement for a electric car, which you would never have gotten before, talking about it over and over and over. Trust me, it's listening all the damn time. I think it's class action lawsuit viable. But the thing is someone actually has to reverse engineer and watch and see what is actually going on. And there is ways of doing that. But I don't think anyone's taken the time to do it because we know it's happening. And it's not even a question. Not even a question. And now you have Windows 11. That's why I did the Life After Microsoft Windows Cutting the Cord series. So people can kind of move away from Windows and get into Linux or another OS, because it is so invasive. It's just, and it's evil. I mean, God, just the idea of taking a picture or a snapshot of your screen every 2 to 3 seconds, and then boiling it all down using your resources on your CPU and GPU, and then sending off to Microsoft that information. What is that information? Well, Chad, if you're capturing someone's screen every 2 to 3 seconds with recall, now they made it so recall is off until you turn it on. But originally, it was automatically on. You had to know how to turn it off. So yeah, it's a big deal. Big deal. Speed Racer, thank you so much for the super chat. Really appreciate it. Made it better late than never. Yes, take a look at it. We went. If you didn't watch, rewind and take a look. We watched Elon talk about his road basically to Mars, and he talked about Starlink, he talked about Mars, he talked about the new super heavies as well as the starships moving forward, and also the time frame when our first rockets are going to be launched to Mars. And according to what he's saying, it will definitely be able to make this next window, and the next window is towards the end of 2026. So if that's the case, I guarantee you they will not be sending up one rocket. They'll probably be sending up like 10 by 2026. And the only way really that they can do it is they need to have a SpaceX Starship that is empty on orbit, and then other starships have to pull up to it and slowly fill it up until it's at max capacity. So this way, the other rockets can go up there, dock, almost like a gas station, fill up, and then take off to Mars. And then another one pulls up, docks, fills up, and then takes off to Mars. And another one pulls up and then fills up that gas station, just like what we have is when we get a trucker come in with the gas and they fill up the gas station. It's the same type of thing. They'll fill in that starship that is actually a gas station, and keep that revolving door just constantly going. So that's how it's going to end up getting done. One way or another, that's the only way that it's going to be able to be done. Let me see. Holy crap! Shannon is in the house with 50 free memberships. Holy shit. Excuse me. That's crazy. Thank you, Shannon. Wow. I'm not going to read everybody, but I'll just read a couple. Look at this. You got Mark Hoffman. If you are there, say thank you. You just got a free membership. Gordon, Greg, Horse Monkey Lover. Horse Monkey Lover? What the hell? Greg. Who else? Jeffrey, Caroline, Nix, Green Party Hat, Phil Lord, Peter, Fred. Anyways, there's a lot that are coming here. Wow, Shannon. Thank you so much for that. All of these people are getting free memberships thanks to Shannon. If you are one of those people, you're being called out because you're watching, you're listening or something, and you're not saying anything. Well, your name is popping up. You're called out. We know you're there now. You have been outed, and you have a free membership. So thank you so much, Shannon. Really do appreciate that. That is wonderful. Absolutely wonderful. Let me see. Ricky Joe says, Google Home Minis listen to my mind say random stuff. Yeah, absolutely. Yeah. So Google is definitely a culprit. Apple is a major one. There's a lot, like Ring cameras. They're constantly listening, even though they don't say they are. There are certain devices that are phoning home all the time, and I don't know. If I had more time, I would build a product that you would stick in line with your router, and it would sniff all of your traffic, and every time something phones home or phones out, let's call it, that you didn't say, you didn't authorize, it will log it. So you would be able to know exactly what's going on. I just don't have the time. But that might be, who knows? Maybe I'll have some time in the future and I can write up something. I mean, it'd be cool. We could use a Raspberry Pi for it, write in Python. Just nothing crazy. Just a simple sniff package, just sniff traffic, like we would do if we were like hacking a network. Not that I do that, but I'm just saying something like that. Yeah. So, Radioactive Texan, hit the like button, please. That would be awesome. Really appreciate it. Let's see. Yeah, our GSE rule says, JC, I want that. Make time, I'll buy it. Yeah, I don't know. It'd be kind of interesting. It'd be kind of. I mean, I write software like it, and it'd be easy to do. But what would be better is if it's an inline device. So someone that is not tech, like a freaking nerd like me, doesn't really need to know what the hell's going on. They'll just get a report, right? It'd be very cool, right? It'd be very cool. Let's say you have a Ring camera or you have something on your network, and you look at this and you're like, oh, this Ring camera not only sent me the information, but sent these 10 IP addresses the exact same information. Well, why did these 10 IP addresses get the information that I got? Who are these people? And I promise you, that's exactly what is going on. So, and the only way to do it is to be able to sniff the traffic. Anyways, I went into a damn... See, just throw on some kicks, all right? Because Fab's not here. I go down like a rabbit hole, and that's it. Shannon with the super chat, official hair, purple hair day. Yes, we got it going on. Thank you, my friend. Yeah, I wish. You're at dinner. There you go. Light it up. Adios. Yeah, I should light it up too, right? I wonder if will these earphone thing, will it reach? It might. Yeah. All right. Shannon, this is for you, Shannon. We're going to light it up because we're going to make believe that Fabiola's right here, but she's not. We're going to see. All right. We're going to see if it sometimes it's just like a short little flame. When my wife does it, it's like this little flame. And then when I do it, for some reason, it ends up like this 1 foot flame. Okay. I don't do anything different. I'm just pushing the button. Anyways, here we go. Ready? Let's light it up. All right. This is for Shannon. Thank you, Shannon. Here we go. That wasn't too bad. That wasn't too bad. I would say it was a good distance. Not bad. Yeah, so you see this. This is the block 1. And how you know it's a block 1 is because when you look at these top flaps, they're at 180 degrees. They're exactly opposite of each other, right? Whereas the block 2, they're tucked in like a bird. It's going fast. So these fins are tucked in. These are at 180 degrees. They're now tucked in at about 130, 140 degrees, somewhere around there, so that they're not sitting in the plasma blast as it's coming in like this, right? And this is just burning up. Not a good thing. So yeah. So that lighting up there. Thank you so much. Enjoy the dinner, Shannon. Thank you for being here. As always, thank you. Let me see. Memorable Places says, the hell with logging the unauthorized traffic. Instead, make it block and wait for permission. Yeah, I mean, that's very easy. You can intercept it, you can block it, however you want to do it. The problem with blocking that type of stuff instead of logging is that chances are it will break whatever apparatus is sitting there, whatever this apparatus thing is, whatever it's doing, it could break it. So I'm just using Ring camera as an example. So all of a sudden, like your Ring information doesn't come to you anymore. So you can't view your stuff because you're blocking that. So I would rather log it and then, I mean, hell, if I made this thing, I probably shouldn't make it because there would be so many lawsuits within a year because I know there would be people logging all this shit, sticking it on their computer, sending it off to their lawyer and say, okay, file. And then the lawyer would be like, damn, this is pretty good. Let's do a class action. You want to do a class action? Let's do a class action instead of just us. We can get a lot of other people on board too. And it would be nasty. And I might not even be here. I'd be like the guy who made the car run on water and he ended up dead. Same type of thing. So maybe I shouldn't make this. What do you guys think? I think it's risky. I think it's risky. Maybe not. Maybe we won't do that. I don't know. We'll see. We'll see. Maybe I'll teach you guys how to make it, and I won't make it myself. Let's see. Kamikaze Ozzy, just have to remember no security cams that don't charge a monthly fee for monitoring. Yes, are not free. Yes, nothing is free, people. That's why when you get Facebook and you use it for free, it's not free. You're paying for it with your data. You're paying for it with your information. That is just the way it is. There's nothing that is free. If you're not paying for it, you're paying for it some way. If it's not with money, it's with something. So, yeah. Let's see. Loving the new XP. Yeah, that is like, so that whole crown with the little XP thing, it's pretty cool, right? That is definitely new. You got like number 1, number 2, number 3 crowns, how many crowns and stuff, based on like your, participation. And that is something that I was hearing about, and I just think that I think it's kind of cool. It just gives like another another vector, right? Another way to kind of analyze stuff. And I guarantee you they probably used this same type of algorithm at the time before they showed this, most likely to determine which people get the free memberships. Remember how Shannon, when he would give a set of free memberships, let's say 50 he just did, which is absolutely mind-blowing, but 50 free memberships, and people would write in, they'd say, how do I get a free membership? What do I have to do? And the answer is you'd have to do nothing, because they pick the people, and it's based on like, how many videos you watch, how much time do you spend on the channel, are you interacting, so I guarantee you there's a litany of things, and that probably one of the things is what we see here now with the little crowns, which is kind of cool. It's probably just information that they've had just laying around. They're like, hey, why don't we just use this information and make it kind of cool for live streams? And then some other dork is like, yeah, we could do that. Let's make it into crowns. Okay. We'll call it like XP. Yeah, and there you go, done. Just like that. Very simple. There's not a lot to it. Instead of doing all this kind of stuff, I wish you would just fix like the chat window. I mean, just fix that so it doesn't do any kind of crazy jumping around. That would be even better. So anyways, I'm going to get out of here. Give me like 3 minutes. All right, 3 minutes. Any other questions, stick them in there now, and then I'm going to head out. And you guys can have a wonderful weekend. Let me see here. Ricky Joe says you should buy an AI fab to have her next to you. Would that be funny? I stick like a, maybe I can green screen it or something. That'd be kind of cool. Stick a robot like right next to me, and it'll be like my AI fab, and she can like read some of the comments and stuff. My wife would kill me. I think it'd just be fun. I don't know. I have to figure out how to do it. It'd be kind of cool. Anyways, see, you give me like crazy ideas. There's other stuff I need to do, but I'll start doing stupid stuff like this, All right. Let me see. For private camera setup, just do a VPN. Yep, you can always do a VPN. VPNs are great. You could double VPN. There's a lot of things you can do with VPNs. I like it, definitely. You could definitely use that. We'll definitely say Honey Badger's here. Thank you for being here, Honey Badger. You're in the house. Say hi to Fabiola. I will do that. Let's see. Let me just go up just to see if I missed any questions. If you have a question that I missed, throw it down there right now. If not, that's fine. Let's see. Moving up through here. Robots. Jeffrey says, do you have to plug the robot to the Starlink dish to get its software updates? Yeah, that would be kind of funny, right? I would imagine it's probably going to have like what? It'll probably have onboard RF, laser. It'll probably have all kinds of telemetry. It'll probably have, obviously Wi-Fi and just a ton of other stuff. I would doubt if the robots will have like a small version of Starlink, like in its head. Think about that, because look, the Starlink dish now, the mini, is literally like the size of an iPad, right? So, and it's able to get like 150 megabits down. It's the size of an iPad. So let's say we chop that thing in half. Okay, now it's half the size of an iPad. It's this big. That wouldn't be that hard to stick into some robot's dome, right? And if that's the case, even if you cut your speeds down in half and made it 50 megabits, and things just like walking around, that's pretty good. That's pretty good. That's not IoT garbage either. Internet of Things kind of crappy service. You're talking about like high speed. You're talking about like really good speed stuck to your robot. That would be interesting. You know, I don't know. I don't know. So, anyways, guys, listen. I'm going to get going. I just want to say thanks to everybody. This was a really interesting week. We had the launch. We had a lot of stuff going on. Elon did his little, I guess, let's say, it's almost like a review of what's going on. Is really what it is, and it's giving us a little of food for thought of where we're going or where the company is going. And it's just fun for me, at least, to see that, because it is definitely positive. So as far as time frame, I also told you in the last video my prediction for time frame for the next test flight 10. I think test flight 10 will probably happen towards the last week of next month. So figure like maybe between June 25th to the 30, like somewhere in that, let's call it the last week. I think that's what's going to end up happening, if all goes well. And if that is the case, we'll probably see another one coming in July, right around the same time. My understanding is it's going to be every month, because they are trying to get to that magic number of 25. And to get to 25, you would have to do 2 a month and still have 1 left over. So as of right now, I think we're going to see most likely a progression, a move that instead of it's like every month or like every 2 months, they're going to start doing every month for certain. Even if they blow it up, they're going to do every month, every month, every month. And then in short order, they're going to do 2 every month. And that will probably happen towards the end of this year. And my hope is that they end up getting this Pez dispenser to work. It doesn't freeze up or have a mechanical problem or have a software error or whatever the hell happened, why that Pez dispenser door didn't open up and they couldn't launch out those satellites. Let's hope that they were able to do that next time that they go up there with number 10. And think about it. It's going to be test flight X. So maybe it's going to be a good one, right? Because we know how much Elon loves X. He calls his son X. So yeah, this will be test flight X coming, and we'll see what happens. It should be a big one. Anyways, guys, thank you so much for being here. Thank you for all of the super chats. Thank you for the free memberships. Shannon, all the rest of you guys, really do appreciate it a lot. Appreciate all the support. We got to the end of a month, and listen, we're up to 135,000 of you now. 135,000. It is crazy, absolutely crazy. When I started this, it was like 60, 70,000 or something. We literally doubled, just about doubled the amount of people in a very short period of time. So I do feel blessed. Thank you so much, and have a great weekend. We'll see you really, really soon. I'm going to leave this open, so if you want to chat a little bit for 5-10 minutes, go ahead and do so, and we'll see you on Monday. Take care, guys. Have a great weekend.